Honors Geometry students, this is Mr. Buxton. Last week's lesson was on how to find the surface area of solids, and this week we're going to work on how to find the volume of solids. So last week we learned 4 formulas. For prisms and cylinders, the lateral surface area was the perimeter of the base times the height of the solid, and the total surface area was the perimeter of the base times the height of the solid, basically the area of the sides, plus 2 times the area of the base, because there were 2 bases for cylinders and prisms. For pyramids and cones, we had similar formulas. The lateral surface area ended up being 1/2 times the perimeter of the base times the slant height. So we can think about the 1/2 almost like we think about the area of a triangle, because the side surface area is coming to a point, and instead of the height of the solid, we're going to use the slant height because the surface is slanted. And then the total surface area for pyramids and cones was that same lateral surface area, 1/2 times the perimeter of the base times the slant height. And this time we added plus the area of one base, because cones and pyramids only have one base. So that was last week's lesson. And now this week we're going to add volume formulas. So there's just 2 volume formulas, one for prism and cylinder, and that is the area of the base times the height. And that should be consistent with our understanding of volume. You could imagine if you had 40 blocks for the first layer, so that's sort of the area of the base, and then you made let's say 10 stories of that, you would just multiply the 40 times the 10 to get 400 total blocks. And then the pyramid and cone formula for volume ends up being 1/3 base times height. And when you get to calculus, you'll end up seeing where that formula comes from. And we're also going to add one more solid here, which is a sphere. And the lateral surface area of a sphere is 4 times pi times the radius squared. The total surface area is the same thing because there's no bases, so basically all of the area is on the side, so we'll just put 4 pi r squared there. And the volume formula for a sphere ends up being 4/3 pi r cubed. And both of those formulas you'll also see in calculus when you get there. So let's look at a couple examples here. First one is a prism. And for this rectangular prism, it doesn't matter which 2 faces we use as bases. So I'm going to use the right and left sides in this case as bases. So we can go up to our volume formula for a prism, which is area of the base times the height. Volume is equal to area of the base times the height. The base in this case is a rectangle. We can find that area by doing 3 times 4. And the height of the prism is that distance between the bases, so that blue segment, which is equal to 10. And so that ends up being 120, and the units for this are inches cubed. Volume is a 3-dimensional measurement, how much space something takes up. For example number 2 here, we have a cone, so we can use our second volume formula because it comes to a point. And so the volume formula is equal to 1/3 times the area of the base times the height. Well, the base is a circle here, and in order to find the area of a circle, we're going to need to find the radius. And so I recognize 26, which is 2 times 13, and 24, which is 2 times 12. And so I see that 5, 12, 13 Pythagorean triple there. So this is 2 times 5, or 10, which means our volume is equal to 1/3 times pi times 10 squared, that's the area of the base, times the height, which is 24. So 3 goes into 24 evenly, it goes in 8 times. So that's going to be 8 times 100 pi, or the volume is equal to 800 pi. For our third example, we have a pyramid, and the formula for the volume of a pyramid, because it comes to a point, is volume is equal to 1/3 times the area of the base times the height. And in this case, we have the slant height, which is 50, but we can use that to find the height of the pyramid. So the height of the pyramid is this segment right here. And going from the center out to the side should be half the length of one of the sides. So this is going to be 30 here. And we have a right triangle. So we're looking for this measurement right here, h. And again, I see a Pythagorean triple here. The hypotenuse is 50, which is 10 times 5, and one of the legs is 30, which is 10 times 3, which means the height has to be 10 times 4, or 40. So we can go back to our volume formula, and our volume is going to equal 1/3 times the area of the base, which is 60 times 60, times our height, which is 40. So 60 times 60 is going to be 3,600, divided by 3 is 1,200, and so the volume is equal to 48,000. For our next one, which is a cylinder, so here we have our two bases, so our volume formula is just area of the base times the height. And in this case, again, our bases are circles, so we can use pi r squared, and we're given that 8 is the diameter, so half of that 8 is going to be 4 for the radius, so our base area is pi times 4 squared, and then we'll multiply that by our height, which is 10. So our volume is equal to 160 pi. For our last example, we have a sphere here, and we're asked to find both the surface area and the volume. So for our surface area, we have our equation 4 pi times the radius squared, and the radius is given to us as 8, so we're going to do 4 times pi times 8 squared, and that's 256 pi for our surface area. And then for our volume, our formula is 4/3 pi r cubed, and our radius again is 8. 8 cubed is 512. So, oops, I accidentally put pi over 3 instead of 4/3. Sorry. 4/3 pi times 8 cubed. And so our volume 512 times 4 is 2,048 pi over 3. So you're going to do some Delta Math practice problems with all these shapes, but we'll go back for a second. Those formulas on the first page, and the key ones here for our new ones are these two formulas for prism, cylinders, pyramids, and cones. So area of the base times the height, and then 1/3 the area of the base times the height, if there's only one base and it comes to a point. And then we have these two formulas for our spheres, the surface area formula 4 pi r squared, and then the volume formula 4/3 pi r cubed. And you'll see all of those formulas on your MCAS review sheet too. So definitely feel free to use those as you go through the practice problems.